This is the 10.2 mini lesson, and it's really about trying to figure out if triangles are unique or not unique. So we need to figure out what those words mean. So if we talk about someone being unique, they're kind of one of a kind. If something's not unique, there's usually a lot of things that are the same. So when we refer to triangles that are unique, it means we are only going to be able to get the exact same triangle. Not unique means I'll be able to get more than one triangle. And this will make a little more sense when we start looking at some examples. So we're going to look at if you're given two line segments. So I'm going to use pasta because I think this makes a really nice visual for what's happening with triangles. So I clearly have two different lengths pasta. So if I want to make a triangle, I could put these two pieces like this. And I could see my third piece would have to go in here to form a triangle. So try to get a visual on what that triangle, well, maybe I'll just trace this. Okay, so if I kind of freehand that in, that's about what that triangle looks like. Now I could take these same two pieces and I could decide to put these angles much closer together. So maybe this time I'll and then when I connect, I can see that these two triangles look very different. I could even make a more obvious if I put these two pieces really close together. And then so I can see these triangles all look different. I'm able to make different shapes given just two line segments. That means they're not unique. We're not all getting one of a kind. We're not all getting, if I gave you every single student in the class these same two pieces and said draw a triangle, and we cut all of them out, we would not all have the exact same triangle. So they are not unique because we are able to get multiple different triangles. Now let's say I take three line segments. So here, actually I'm going to go back to that. I'm going to just sketch out a picture that kind of references what we just talked about. So I could put, in both cases, A is the same length and B is the same length. Here I opened up the angle more. You could see C is quite a bit longer. Here I closed in the angle. C here and C here are not the same length. So we did not get a unique one-of-a-kind triangle. These triangles are different, so that's not unique. If I now want to go to three lengths, three line segments that are given. So if I gave every single person in the class these same three pieces of pasta, and I said make a triangle, so when you start to play around with these, the only way we're going to get a triangle is we have to just finally keep closing in these angles until it fits. And it looks like I finally have it. Every single person in the class would have this exact same triangle if I gave the exact same three pieces. It's the only way I can fit them together. If I try to move it around a little, maybe I switch a couple of pieces, still I can't make a triangle until I start folding this up to get all these to come together. And when I get them all to come together, if we would cut them out, everybody in class would have the exact same triangle. We might have it tipped a different direction, but it would be the exact same triangle. This is an example of unique. So what I tried to show here is, again, I took the same A and B, but if I made it at this angle, this is the length of C. If I opened it up, C ends up being longer. If I close that angle, it's shorter. So these three are not all the same. There's only one way I can get all of them to fold up together. It would only give me one triangle, therefore it's unique. Now, if we're given three angle measures, this one I can draw out a little easier. I know what a 90-degree angle looks like, so let's say I had a 90 and a 45 and a 45. I could see that I could have a real little triangle like that. In fact, if I take a corner of the paper and if I would cut this so that this is 45 and this is 45, this is 90. But I could do that up here and make a bigger triangle. I still have a 90. I could still have a 45 and a 45. So this big triangle, this little triangle, have the same angle measures, but they're clearly not the exact same size. So again, given three angles, we do not get a unique triangle. Some of you are going to have a bigger triangle. Some of you, your triangles will be smaller.